Hello, my name is Marcos Vinícius. I am a researcher at SEMETRO in the area of electrical calibration, and I will present the paper called A Reference System to Calibrate Low Current Meters in the Range of Picoamperes to Microamperes. This work is divided into two parts, one focusing on the software and the other focusing on the system. The presentation here is the one that focuses on the system, and this work was developed in the electrical division of SEMETRO by me, by Rodrigo Ventura, by Regis Landim, and by Rodrigo Davi. The presentation structure is shown now. Initially the introduction, talking about the motivation of this work, then the part of materials and methods used to carry out this work, and next we will present the results obtained. Finally, we will present the conclusion of this work. At SEMETRO today, we have our measurement and calibration capabilities from 100 amperes to 10 microamperes. In the areas of optics and symmetry, we need traceability for currents below 10 microamperes. Our main objective is to serve the dosimetry area. Clinical dosimeters are electrometers coupled to an ionization chamber, and they work in the range between 1 picoampere and 100 picoamperes. Between the 10 microamperes range and the 100 picoamperes range, we have a gap. This work provides an option for a calibration system from 20 microamperes to values in the order of a few picoamperes. The main objective is to serve the dosimetry area through the calibration of electrometers, especially in direct current in the range mainly between 1 picoampere and 10 picoamperes. The BIPM recommends three different methods for realizing the magnitude of electrical. To validate the system using the Ohm's law method, it was necessary to compare the values obtained with the developed system with the values obtained with the current laboratory system. This comparison was performed by calibrating the 20 microamperes range of an electrometer using both methods. The current method used in the laboratory is the method of comparison with a standard current source. The implemented method is the Ohm's law method. We use a multifunction calibrator as a standard current or voltage generator, depending which method are in use. A set of standard resistors was used, and all measurements were made in a Faraday cage. A software was developed to make this calibration, and the details are presented in a second paper called A Software to Calibrate Low Current Meters in the Range of Picoamperes to Microamperes. The values compared were 10, 15, and 19 microamperes in the forward and reverse directions. The normalized error between measurements was less than 1 for all points, showing that the results were satisfactory and that the calibration system can be validated. Below the table, you can see the graph that shows a series of measurements performed with both Ohm's law and the comparison with the standard current source method. This table shows the relative uncertainty values for each range using the Ohm's law method. It was possible to obtain uncertainties between 6 microamperes up to 23 microamperes per ampere in the range of 2 microamperes up to 20 microamperes. In the range of 200 nanoamperes up to 2 microamperes, the uncertainty obtained was 48 microamperes per ampere up to 7 microamperes per ampere. In the other ranges, one can see all the values, and the maximum uncertainty was 0.66% between 2 picoampere and 20 picoampere range. This value, 0.66%, was in the 2 picoampere point. These uncertainties shown in that table show decrease as we get more reproducibility data. The values shown here are the initial values. More studies are made and the values are decreasing. This graph shows measurements in the range of 20 microamperes on the left, and on the right we have the same graph but with the inclusion in red of the calibrated equipment manufacturer specifications. It's possible to notice that the calibration uncertainties are considerably smaller than the manufacturer's specification. This next graph shows measurements in the 2 microamperes range, also indicating the manufacturer's specification to the right and the same graph. This graph shows the range of 200 nanoamperes, with the uncertainties far below the manufacturer's specification. This graph shows the range of 20 nanoamperes, with uncertainties also well below that specified by the manufacturer, as shown in the previous graphs. The 2 nanoampere range shows slightly different behavior from the other ranges, but still with much lower uncertainty than the manufacturer's specification. This different behavior between forward and reverse direction of the current is explained by the adjustment mode of this equipment, which has a separate adjustment for the positive part of the range and the negative part of the range. This next range is the 200 picoampere range, with satisfactory values and uncertainty lower than the manufacturer's specification. Finally, the lowest range available on the calibrated equipment, the 20 picoampere range, also has lower uncertainties than specified by the manufacturer. With that, we can conclude, seeing all the ranges, that the calibration system using the Ohm's law method was implemented and reaches the necessary values for the calibration of the electrometers used in the SEMETRO area. These values and uncertainties will enable the validation of the capacitor charging method that is being implemented in the laboratory. With the system implementation, SEMETRO expands its measurement and calibration capabilities in direct current by 6 orders of magnitude. We, therefore, concluded that it is possible to calibrate direct current below 20 microamperes to the order of picoamperes with satisfactory uncertainty, and soon we will be able to offer this service to our customers, such as industries, calibration laboratories, and research laboratories. Thank you. If you want to know more about the system or any doubts, feel free to contact me or any other author. Thank you again.